results here. Recently, Marcelo, he could measure the strength of the magnetic field using polarization, the Zeeman splitting of the water maser emission in the Roden egg nebula. And there is also this result for this star in which the magnetic field is of a few milligauss, and it seems to be dynamically important, and well, also the shape could be an inclined colloidal field. And as mentioned by Riviera as well, that there is a source, IRAS 15445, that we found synchrotron emission, but this would be discussed in more detail by Andres, so I will just skip this and wait for his talk. I don't want to screw the presentation of this. and well, also there has been some modeling work, magnetro hydrodynamic HV planetary nebulae model, and magnetic wind of Betelgeuse. So yes, there has been also a lot of let's say new work that has come up in the field of modeling. So just quickly an outlook on ALMA, what we will be able to do in the future, in the coming years, with this instrument that all people are talking about. And well, ALMA now will offer, obviously it will offer a possibility or capabilities to carry out polarization observations, and we will be able to carry out the observation of the Zeeman effect in known maser lines, also the Wolf-Wright-Pilates effect. What we did in a full track with the SMA, now we will be able to do it in a few minutes. Then we will be able to do also the continuum dust polarization and maser polarization. And for the next cycle, the cycle 2, ALMA will offer the continuum polarization, although not line polarization. Hopefully it will offer it in the next cycle. And for the case of the Zeeman effect in long lines, then here are the bands which we will be able to do that, and here are the molecules for which we will be able to do that. And for the case of the maser lines, these are the tables with all the information. Actually, this is a paper by Andres Perez Sanchez, so we can ask him a lot of questions about this. And well, just actually in this paper, he made a very good work on predicting the amount of polarization that we will be able to detect that is result of the magnetic field. And then, so actually this paper will be like a reference that we have to read in order to interpret our data. So it seems that up to 20%, when the polarization degree is up to 20%, we can tell that the polarization comes from the magnetic field. Otherwise, there are some other effects that create, let's say, polarization. Actually, there is a way of producing circular polarization from linear polarization through this anisotropic resonance scattering, so we have to take into account all these kind of things when we carry out these observations. Finally, the ALMA will map the circumstellar envelope, so we can compare the CO and the magnetic field morphology. We can also discover binaries where we cannot see through indirectly. For example, in the case of R sculptures, in which we think that there is a binary system, given that there is this spiral structure. It has been modeled that the binary system will produce this morphology, and we can also probe extreme outflows like the one in the Boomerang Nebula and the red rectangle. So these are the conclusions. It seems that the magnetic fields are dynamically important, and or the dynamically important large-scale magnetic fields appear here and there in the envelopes of the evolved stars. That they appear at many distances and they show the power law, so they seem to be consistent with the power law. And well, there are many new results that we will discuss all over this conference. That there will be many new results. And well, then there comes ALMA. Like many people say, ALMA will solve all the problems that we have. So we hope that also it helps us in this field as well. Just finally, I just want to make an advertising. These are two students of Walter, and they are about to finish their PhD. So they will be, actually they might be already searching for a postdoc. So if you are interested, please go with them. You can see what they can do. If it is useful for you, you can just go and speak to them. So I think this is it. Thank you very much.
Well, that was really good for someone who didn't write the talk.
I started studying it like yesterday.
This is incredibly interesting work. I'd like to just comment that the magnetic field, the observational side of that, it seems to have exploded since the last. Any questions?
Just a question about the interpretation of the large-scale nature of the field that you can sort of track from one to the other. With these sources, how well?
He's a theoretician. He'll never get it.
So, how well can you tell that there's no substructure in the nebula or in the wind? Because in some sense, I'd expect if there's any shocks or anything moving around, that you'd actually mess up that nice power law. I'm surprised by the power law, if unless it's a very quiescent.
Yeah. Can you hear me? Well, actually, as you can see in the it is not actually very well constrained. It has very big boxes. Yes, the measurements, they fall within those boxes. So in principle, yes, I mean, it's not like a very nice, smooth power law, but there could be some variations, and yes. But let's say, I guess that what is important here is like the general tendency. Yeah.
And let me follow up with my own question.
So,
the magnetic field we see may be the magnetic field that's most advantageous at its location, that is, where it's most compressed. So it's hard to say whether this characterizes fields in general or just the emitting regions. Would you agree with that?
Yes, and like I actually mentioned in the beginning, actually this is an answer question, like whether the magnetic fields are actually responsible for the shaping, or there's some other mechanisms shaping, and then you get this distribution or this power law of the magnetic fields as a secondary effect.
Well, certainly the interplay between modeling and observations would be vital for exploring this concept.
The remark on the question, to begin with, I find it very sympathetic that you advertise your younger colleagues. I commend you for that. The second thing is, quite a few of your observations show just a few resolution elements across, and yet you had all those field lines aligned very nicely. Now it is correct, isn't it, that per resolution element you have only one direction, so it is rather too suggestive, in my opinion, of an organized field. The second thing is that this kind of stuff is optically thin, so it's still, not only do you have a few resolution elements, but also looking along a tube, actually, rather than a patch. Yes. So what can you really say about the field configuration?
Well, yes, actually, the thing is that this field is kind of the average field of a beam. Actually, this could also suffer from, I mean, you could have different orientations of the field within the beam, and you're just averaging over the whole beam. So in principle, yes, in that sense, I do agree that it might not be as well distributed, or yes, but it's an effect of the observation. So in that sense, higher observations would be required to give more information.
So thank you very much.